Hello Linux lovers, my name's Wimpy, welcome to my world. It's more Retro Home, my Raspberry Pi operating system for retro gaming built with Ubuntu. Hello Paul, hello, good morning, how are you doing? If you're watching this after the fact on YouTube, this was originally streamed on twitch.tv/Wimpy's World. I stream every Monday, Wednesday, Friday, so if you'd like to join in interactively with the rest of the community, some of whom are already here, then please come and give me a follow at twitch.tv/Wimpy's World. Morning, Yannick and Paul and Graham and Rich and King Egypt. Hello, welcome back everyone, how you all doing? Happy Friday. You ready for the weekend yet? I know I certainly am. Although I've got 4 days of solo parenting ahead of me, so it's going to be a busy weekend. So we're going to be looking at Retro Home again. Specifically, we're going to be looking at sort of system plumbing of Ubuntu and how to optimize Ubuntu and some of the services and some of the way the system is brought up, particularly for Retro Home, in order to minimize those boot times and minimize the number of processes that are persistently in memory, because we need this thing to work on not just a Raspberry Pi 4 and a passively fan cooled case, but also in handheld devices. Hello, good morning. Hello Yannick, thank you for that. Yannick's been ready for the weekend since Monday. Right then, so I've got a few bits to look at, and also new card reader, which I said I was going to be getting, has arrived, and that has been edifying. What I've learned about card speeds, I have a new recommendation for the king of cards. I'll get to that in a bit. So let's jump straight into this. Never release on a Friday. Maybe I will, just to throw. I don't think I've got time to get an image uploaded, but this is the project. This is Retro Home. This is basically a build script, but we're getting dangerously close to having this ready to actually upload like a generic image so people can more widely test. At the end, I'll sort of summarize where we are and where the next bits of the project are going to be for Retro Home, and it's much more interesting stuff. Although I love all of this system's internal stuff, it's that's what I'm all about. So let's take a look. We have got the code editor up here. I've made a bunch of changes recently, and I'm going to go through some of them because I've learnt some stuff that I think's really quite cool about systemd. So I'm going to go over some of what I've learned and some of what has changed, and we'll start where it starts, in fact, which is here in the bootstrap stage. Hello, ascertainment. Hello, is that how we say that? Hello, welcome. So this has changed. This is the process, the very beginning of the building the image process that uses dev bootstrap, and what you can see here is this excludes line has grown quite considerably. So why is that? Well, there's a couple of things to bear in mind. One, we want to kind of keep the services to a minimum because we do want to target handheld devices, but also Ludo, which is our front end to the libretro cores, uses Conman as its network manager. So we can eject a bunch of stuff from the base image before we even start building the OS that we know we're never going to need. So some of that is what this is about. When we look here at the DHCP client, we simply don't need that. Netplan we already knew we didn't need, but the library was still being pulled in for reasons I couldn't fathom, so we're dropping that out. And similarly, we don't need network D dispatcher, which is part of systemd for network notifications about routing changes, because again, Conman is doing all of that for us. And then naturally, we don't need Vim. So these are all of the bits that are to do with Vim. So we're going to eject those from the very beginning, and then naturally make sure that Nano is included, because Nano is better in every objective measure. And then everything else you see in here that wasn't one of those things, this is just stuff that adds not bloat, but things that are unnecessary for the purposes of Retro Home. So we don't need these internationalizations for debconf. We don't need distro info. DM setup is useful, but we're not making a NAS or anything like that. We don't need to be able to eject CD-ROM drives. So there's just a few bits in here. You know, netcat, you can say, is always useful, but why do we need it on this? So just removed a bunch of things. That keeps like the package count down a little bit. So that's the initial bootstrapping stage has been tuned. And then further on, what we then do here is we do a bunch of service cleanup early on in the process. So these we already had in the build steps, but further down I've now put them at this point here. So this is disabling all systemd networking services because we're just going to be using conman. And similarly, we're disabling cron. I can't prevent cron from being installed, but we don't need cron at all. And that's because if you go and look at most of the cron tabs that automatically get installed on your Ubuntu system these days have got a conditional at the top that says if systemd is present, then just exit, because there's already a systemd timer. So after having analysed all of that stuff...
Thank you for the follow, Beardy Chris.
Hello Beardy Chris, welcome to the stream. Thank you for the follow. So after having gone and analysed that, there are no crons that are not already available as systemd timers. So we'll just disable cron. The purposes for doing that is preventing anything from running that we don't want, but more importantly, one less process in RAM all the time. Ubuntu has a message of the day customizer. I'm not interested in that. In fact, we now have our own sort of static configuration for mopd for retro home, so we'll disable these timers. They simply don't need to run, and although these aren't persistently running, this is one less thing for systemd to look at. So this ever so slightly improves boot performance, only by like 40 milliseconds or something, but you know, aggregation of small margins and all of that. I've then taken the decision to turn off all of the routinely scheduled apt activities. I think I may implement something of my own at some point in the future, but for now, we don't need this stuff. I see there's a question here that says it's massively off topic, so let's have a look. So let's naturally, of course, you know, Yannick is outraged I have removed Vim, but who needs Vim? Only animals code with Vim. Rich Codes is on message here. Yeah, it is nano is the only thing you need. And then what's this about? Agree, but you never know. Never available when you log into a server during an emergency. I've never logged into a server without Nano being available for many years. And then here we go. So it's only a GNOME says this is off topic, but does anyone have a definitive guide to command line install of Mate on top of Ubuntu 22.04 dev battery? I found a million out of date broken guides. Well, I would have the definitive guide. So if you just deb bootstrap in a usual way, you don't need to tune it, and then you need to install Ubuntu Mate Core with the caret. I'll show you what I mean by that. So let's assume you've bootstrapped a base image. You would do this, Ubuntu Mate Core with the caret there. That pulls in the task, not the meta package, but the task. And when that has run, you do the same, and you do Ubuntu Mate Desktop, and that will get you an Ubuntu Mate install on top of a deb bootstrap that is pretty much equivalent to how the ISO image is constructed. So there you go. Hopefully that helps. Right then, so let's come back here. So we're turning off a bunch of stuff. And I didn't need this VT service because I've implemented my own splash screen, and we'll get to that in just a moment. So there's no disabling of Plymouth here, and that's because I've disabled that in other ways. So I've disabled that using kernel parameters in the command line.txt file that the Pi uses to tell the kernel what to do. And we've not got Plymouth in the mini images at all. And in those desktop, in the versions that have a desktop embedded, there is a Plymouth, but it's completely disabled. And I'll show you what I've replaced that with. And then at the end here, I went through by hand looking at the packages that were in Ubuntu Standard, which is like the Ubuntu Standard user space tools. And again, I'm not trying to build a for humans command line, distribution. I just want enough to be able to sort of use the system and do the bare minimum. So these are the bare minimum tools I think that I need on the system in order for, if you SSH into it, you should have everything you need to, debug, diagnose, get yourself out of trouble, that sort of thing. Hey Henrik, how you doing? Yes, Yannick, you did spot cool retro term. I was trying to think of ways to just add a little bit of visual appeal to some of the bits on the stream. So this is a new addition to just fancy up the terminal stuff on the stream. So that it does reduce the size of the image, but only very slightly. But really what that's about is the reduction of persistently running services, because we care about RAM. When we start looking at the Pi zeros we're going to target for some of these devices, we've got 512 megs of RAM to work with. We want to save as much as possible wherever possible. So I don't think a great deal has changed in the Ludo stage. This is the bit that actually brings up Ludo itself. I think this is, although it may have been restructured slightly, it's about the same. The bit that does change is this piece here. So we're now using our own splash screen, and that's done with two aspects of systemd, and I learned something new here. So the first thing I learned was, if we take a look at this, we have a udev rule here that let's actually type the correct path in, shall we? There we go. Have a udev rule here, and that instructs systemd when this device becomes available. So it's a way to sort of link the dependency tree of boot with devices that become available. And then we have this service here, and this is my first stage of the boot splash, and it uses a tool called FBI, and FBI is an image viewer for the frame buffer. So all this does is wait for the frame buffer device to become available, and then it displays this image, and we'll get to see all of this later. And that's all it does. So this is the initial, so this splash image is actually the Retro Home logo, black screen, Retro Home logo, just a static image. So that's the first piece of the boot splash, and this is my poor man's implementation of, or equivalent replacement for Plymouth. So I see there's a lot of chat here. Let me just hey Popey, how you doing? No, it was. I know it's easy bait though, isn't it? Get people riled up about the editors. Of course, I'm using Visual Studio Code because that is the one true king of editors. So this is the initial piece to replace Plymouth, and what I found is can significantly speed up the boot process by completely ejecting Plymouth from the process, and I can also manage that boot transition on what's displayed on screen and when it's displayed on screen much more precisely if I don't have to deal with Plymouth. So I'm quite happy with the results, and we'll have a look at that in a moment. Then we've got our when we're building the mini system, bringing up the display server. This has had some improvements to actually chain from this frame buffer display. So we get the frame buffer display, and then this can correctly hang up the VT, so we can have the display server brought up on the same VT that we put the splash screen on, so we don't get all of this jumping and fritzing around as we go through the stages of boot and displaying images on the screen. And then I've started to add some of these maintenance service units here, so we'll just take a look at this one. I'd been having some difficulty with the font cache not being correct on the system. So this is a very simple systemd unit that says if the font config cache directory tag is missing, then rebuild the font cache. And what I do is in the build system, I deliberately delete this file in the last stages of the image preparation so that this is always true on first boot. And the reason for doing this is that we only actually have 2 fonts in the retro home image. Again, we've kept everything as minimal as possible. We've got rid of all of those old X fonts. We've just got 2 true type fonts, the Deja Vu fonts and the M+ fonts, which we use throughout the system. So actually this doesn't take long to rebuild the image cache, which is nice. And then this is a whole bunch of stuff to build our boot animation, and I'll show you what that looks like in a little bit. But this is basically just building a bunch of images using the retro home logo with a progress throbber, so that after the static image has been displayed, we have another piece in the boot splash which then animates, so you get some sort of visual feedback that something is happening whilst the rest of the system is brought up. One change is we've had to go back to WPA supplicant. It turns out that Conman cannot scan for wireless networks using IWD. That hasn't been implemented yet. So I've had to go back to WPA supplicant in order that we have better Wi-Fi support. Wow, okay. So, oh, yeah, okay. So Rich is a fan of the JetBrains. JetBrains makes some fine editors, that's for sure. I like that I can have one editor with everything I need for the different languages. No changes to the Pipewire stuff. Pipewire is still default. I'm probably going to drop the Pulse pieces. I'm keeping it because I'm considering at some point adding support for some different emulators, so specifically like Commodore 64 and Spectrum emulators, and they may require Pulse, but I don't think they will. I think they'll be able to speak to the socket that Pipewire creates. Certainly a lot of the audio setup I'm doing, I'm just using Pulse tools and it's talking to the Pipewire socket and it works beautifully. But Pipewire is much better at handling the detection of the correct audio devices. Then this is all the same, installing debget. Installing debget also installs bits and pieces and brings up the unattended upgrades, which I also disable. The reason for that is if you've got a handheld device and it's powered by a Raspberry Pi Zero, at boot you don't want all of these apt update services running because it really bogs down the performance of the device. So we're focused on here just getting a device that you turn on and is as usable as quickly as possible. Now this is new interesting stuff, and this helps the boot experience quite considerably. So I found out there's this concept called systemd drop-ins, and what this allows you to do is effectively override portions of an existing systemd unit. So what I was doing is, in order to integrate with Ludo's menus to say toggle SSH and Samba, it creates a file basically. And what I was doing was letting the SSH service start normally, and then I had a unit which was directly after it that said, well, has Ludo got SSH disabled? If it has, stop that service. So at boot time, you didn't get any efficiency in disabling services because they would all get started and then they'd all get turned off, or they'd get turned off afterwards. But now what we can do is this. We've got these, in fact, you can see how it's prepared here. So for Bluetooth, Samba and SSH, it will just write this condition path exists into effectively an override file for the existing unit. So now the actual units themselves will either start or not based on the Ludo preferences. So what that's enabled me to do is I've had to think about it, and I thought, well, we don't need Samba enabled by default because that's now just a toggle in the Ludo preferences. So I have Samba disabled by default, again, to help that first boot performance. But if you need it, of course, you can just go in and turn it on now. So I'm very happy with this, and this is a neat feature of Systemd I didn't know existed, and it's super helpful. And this is new. So again, what we're doing here is we have Samba. Samba has a single config file, and it's etc samba smb.conf. I move that to one side to keep it as like the distribution version, and then we write our own global configuration in here to the same location, but it just says actually the configuration we're going to use is over here, and that's the configuration that we supply as part of Retro Home. And then we also instruct it that the NetBIOS is disabled. And then we write out our own bespoke configuration, and then we have a Systemd unit down here which actually enforces that policy. So you can't go in and mess around with the Samba configuration. It's going to always use one that is compatible with Ludo, and this is just sort of like trying to manage technical debt. So this one's very simple. If we have our bespoke configuration, then always overwrite the regular configuration to tell it to use the one that we ship with Retro Home. So this is just trying to help prevent, if there is a package update and the Samba configuration is overwritten, this will ensure you always get back the correct configuration for use with Retro Home. So it should prevent that clattering of files that happens when some things get updated. This is all the same, except here we remove the enablement flag for Samba, so it's disabled by default. And again, we've got another unit file here. Because Ludo in Ludo OS mode expects that it's running on LibreElec, it has this update facility. So what we're doing here is to prevent anyone from clicking on that and downloading a massive LibreElec update image, we're deliberately setting the permissions on that update path to be unusable. And then we also have another Systemd unit which enforces that policy to make sure that you can't unwittingly go and initiate a LibreElec update on an Ubuntu system. What I intend to do in the fullness of time is actually submit a patch to Ludo to change the behavior when it's not running on LibreElec. Ideally hide that update mechanism, or, as I was alluding to earlier, replace it with my own for Ubuntu so that we can have an updater, you know, within the OS. Hello Tommy, welcome, welcome. So let's have a look here. So Rich has been explaining why he likes the JetBrains stuff. I do like their editors, they're very good. So we talked about this policy kit stuff, we all know about that, and then this is new, and I'll demonstrate this a bit later. So we're installing the iNotify tools, and that's because I've added this thing here called Watch Ludo Settings. So we'll just go and take a look at that, and I'll go and explain, go away. Just go and explain what that is. It's a bit of frippery at the moment, but in the future it could be very useful. So let's explain what's going on here. So we have this, this is where it enters. So the path to the settings, this is the path to the Ludo settings. And we just check that that exists and is readable. And if it is, we set up an iNotify wait on that file looking for close write. So that means, has that file been written to and has that write being completed and the file closed? And if that has happened, then we parse the config. So TOML files are a bit like Windows ini files. So here's a bash function that passes out all of those settings and defines a bunch of variables based on their content. And then what we do is this. We say if we've got the G schema available for the desktop interface, so this is basically saying, is there a desktop install on the thing, then change the desktop theme based on the preference in the Ludo settings of video dark mode. And I'll demonstrate this later. But that calls this function here, and it says if dark mode true, then set the desktop environment to dark mode. And if it's not set to true, then set the desktop theme to light mode. Now, that's a bit of frippery, but it's a good sort of visual indicator that the process works. What I'm thinking this could be good for in the future is, I've already explained, we've got those toggles for like SSH. I'm thinking I could add something like SSH guard to the base install. I can add the same conditionals to SSH guard so it only starts that service via systemd when Ludo says SSH is enabled, but Ludo itself will only enable and disable SSHD. But I could add a piece in here that enables and disables SSH guard when the SSHD toggle is toggled in Ludo. So it would enable us to do some additional things, to add like an additional protection around SSHD and turn that on contextually. And similarly, you can turn on and off Bluetooth. Now on a Raspberry Pi, there's a bunch of other services around bringing up the Bluetooth device, and they're quite slow to initialize. So I'm thinking I could put the same conditionals on them so they don't get started at boot if Bluetooth is disabled by Ludo. But Ludo will only start the Bluetooth service, but here I could add another check to say, well, if Bluetooth's just been turned on, actually go and bring up these other services that bring up the rest of the devices on the Raspberry Pi that make all of Bluetooth happen. So this is kind of something for the future, but I've just implemented something to sort of demonstrate that it does something in air quotes useful. So that's sort of an integration capability for the future that we'll take advantage of, I think. This I don't think has changed, other than putting GNOME terminal in. We disable all of the tracker services very quickly early on here. All of this is the same. I'm probably going to remove Vivaldi. I've done some testing. I've got some ideas about how we could improve the browser options, but that's a ways out. So we'll just leave it as it is for now. All of this is the same. We've got some icon generation. This is all sensible stuff. I've added in some optimization steps. Just keeps those image sizes down a little bit. They're not massive, but it all adds up. Same for the background image generation. I don't think any of this has changed. And then I've just got a little customization I'm working on for the desktop session itself, which hopefully we can check if it's working correctly. All the kernel stuff is as it was. I don't think there's anything new here. This is all doing the same stuff. I've dropped some unnecessary packages from there. This is to facilitate the boot splash, disabling TTY1. All of this is the same stuff. That's all fine. And I think the configuration broadly is identical. Oh, here we go. So we turn off all of the message of the day customizations that Ubuntu ships with, and then we replace those with some of our own that don't reach out to the internet to update. They're static. So again, just keeps the number of running processes to a minimum. That's all part of the build process. This is the case enablement stuff. None of that's changed. And then there's a bit of cleanup here in the way that the actual cleanup of the image works. Nothing significant, just a few files tidied up. Big change though is this here. So accurately calculates the image size now. And we'll see firsthand what that looks like in just a moment. So someone asks here, silly question, what are you using to build the images? So this script, and as Yannick says, there are no silly questions. So this script is the script that builds the image, and in fact this stage of the script here is the bit that what happens is it uses a container to build the file system, and then this function here actually turns that file system into the image itself. And this piece here, we know that, well, this defines how big the boot partition is, the bit with the Raspberry Pi firmware and bootloader on it. So that's 256 meg. And then what we do here now is we calculate the size of the root file system. We then calculate 5% of that, and then we calculate the size of the image, the thing that you put on the flash card, as the size of the boot partition plus the size of the root file system plus 5%. And what this means is now our images are always exactly 5% bigger than they need to be. So you just get like 90 or so megabytes wiggle room in the image. So the advantage of this is when this piece runs and it has to initialize the file system here, it's not initializing a file system that's 2 gigabytes bigger than it needs to be, and therefore taking longer. And I'll get back to why this is important in just a moment. And it also means that when you write that image to a card, it writes faster because there's fewer bits to actually put out and all the rest of it. It's smaller to download. You know, there's a whole bunch of side benefits to this. And we use Validate now rather than DD, and that's so that we can get a correct 512 byte boundary divisible image size, which is all good for the sort of on-disk performance of the file system. But some of these optimizations that I've made are in the build process itself. Fewer packages to install means that build process runs quicker, means the images are smaller. These calculations mean the images are smaller, and that's because Tackov and I have been talking about getting this build process into CI/CD at some point. And the time it runs for and the size of the things that it produces become more important. And we'll look at, you know, there's some quite significant savings being made here. But this piece here, you know, your question was what are we using to build the image? It is this script, and this is the piece in the script where it takes that file system and then generates the actual image itself. So you can see we create two partitions inside the image that we make. One FAT for the bootloader and one ext4 for the root file system. So, and then this piece I'm not running at the moment, but that's XZ compressing the image, and that will be like the version for people to download. Hopefully that helps a little bit. Oh, Sparky Geek has spotted a typo. Hello there, Adam. Welcome back. Let's see. So it says there's a typo in calculate partition. There is. Check it out. Look at that. Thank you. All pair programming accepted. So, I think that kind of describes what I'd got to. Let me just take a look. Let's just get rid of some of these that we opened up here. So I think what we should do is get to seeing it in action. So I've talked about, you know, the bootstrapping, service and timer, Samba, Systemd drop-ins, my new most favourite feature of Systemd. If you don't know what it is, go and just Google Systemd drop-ins or Systemd drop-in snippets. I don't know how that passed me by, but I absolutely love it. It's great. We've looked at maintenance units. I've talked about the boot splash. We'll have a look at it. We've got that settings watcher. We'll actually see that in action. It's kind of fun. We've got a custom motd, so we'll have to have a look at that because it's amazing. Image size calculation, and then new card reader. So let's look at that. So let's just go back. Oh, come on, brain. So I was talking about my card reader being incompatible with some cards. So I've got this. It's a SanDisk Professional. It was fairly expensive. I think it was like 80 quid, and it's a multi-card reader writer. But it claims to be fast, and I've got other card readers that also claim the same specs. Turns out this is considerably faster with all of the cards that I own. It's like I've never seen the cards be used properly before. So it is night and day, and for me, when I'm writing these things out, because I'll have maybe a few hours in the evening, a couple of evenings a week to work on this stuff, the less amount of time I'm waiting for things to happen, the more productive I can be. So that £80 investment is worth it. And then the other thing I will add to that is I talked about these SanDisk Extreme Pros. I've tested these alongside the Extremes, slightly cheaper versions. I have now decided these are worth the extra because the 64 gig and the 128 gig have effectively the same performance. This one, the 128 gig writes at about 115 megabytes a second. This one writes at about 105 megabytes a second, so very close. Whereas in the extreme range, these ones write at about 70 megabytes per second. So there's quite a drop off on the smaller size cards. So I've decided that for the slight uplift, I actually prefer these Extreme Pros for the turnaround time. What I haven't tested, and I think will be something I'll look at in the future, is how do these different cards...
Thank you for the follow, Soupdom.
Hey Soupdom, thanks very much for the follow. How these different cards with these uprated specs, does that translate to any benefit in system performance when they're in a Raspberry Pi? Because how good is the SD card reader writer in the Raspberry Pi? So I'll be taking a look at that because I'm just curious to know. And Sparky Geek so says Systemd drop-ins game changer. Really are. I don't know when they turned up, but they'd passed me by. But I absolutely love it. It's just all things are possible now. It's just fantastic. Really, really a big fan of that. And so I've been loving working with Systemd. I'm using Systemd for a whole bunch of different things now, and I've always been a fan of Systemd, but I've learnt a few new things about it, like how to sort of bind device requirements to service bring up. It's just fabulous. Really like it. Anyway, so I've actually written one of these card images out, but let's take the bigger one and rewrite it, because that will show us something about, well, what did all of these optimizations do to the image size? So let's take a look at that. In fact, let's do that by pushing the right button. So we go and bring this down onto this screen here. It's a little bit off, but anyway. So here are the builds. Now I'll just highlight, this is a full size image before these optimizations. This is one that includes a desktop, and that image weighs in at precisely 4 gigabytes. And with the optimizations that we've made, this now weighs in at 3.3, so a 700 megabyte saving. Some of that is due to the more accurate image size calculation, but we have shed some packages along the way. But it's more pronounced when we look at the mini images. This is what we had before at 3.5 gigabytes, and now we're a whole 1 gigabyte smaller. Smaller is better in this regard. Smaller is fewer packages, fewer services, smaller memory footprint, faster boot performance. There's a whole bunch of upside here. So we're looking at some decent savings here, and these will compress quite nicely as well. So and then of course we don't have to have the swap partition in those images, because again we're using systemd to bring up the swap partition early in the boot process, and we're using ZSwap as well. So everything's tuned. So at this point, once we're satisfied all of this stuff is working, he hastens to add, we'll be moving on to some very different aspects of bringing this system together in future streams. So which card did I just put in there? The 128 gig. So we will write out the larger image. So this is the image with the embedded desktop, and we will start this. So don't blink because you might miss it. So this is using the new card reader, and we can see here that the write performance is a sort of a sustained 113.5 megabytes per second. This card in my other card reader, which is was one of these, which is also on the same USB port, was writing these card images out at about 90 megabytes per second. So it's quite the uplift. And for the other cards, this was significantly slower. So there we go, it's done. So I'm very happy with this new card reader. What's interesting is this card reader, which is plugged into a USB-C port on the front of the case, is faster. I've used it at home as well. It's faster at home than my integrated card reader writer that I've actually got in the chassis of the case, and that's directly connected to the USB 3 headers on the motherboard. So there must be something in the quality of like the chipset of the the controllers in these things that separates them, because this is by far and away the fastest card writer I've ever used. Irrespective of which card I put in it, each of the cards are performing to their maximum potential with it. So I'm very happy with this acquisition. Why is it chonky? Why is it chonky? Well, it's a SanDisk Pro. Oh, hang on, let me just move here. So King Egypt is asking, what on earth is in that card reader? It's chonky. So it's a SanDisk Pro, if you can just make that out here. And it's, I don't want to disconnect it. It's micro SD, SD, and compact flash. But it's professional, so this is metal, and it's heat dissipation, and it's ruggedized and waterproof and shit for photographers and things, I imagine, in the field. But from my point of view, fastest card writer I've ever used, so that's why I like it. Right, so we're done with this. I'm going to eject this. So eject that. Click over here. There we go. So I prepared the mini version as well on a card writer earlier. What am I doing here? Why can't I? Oh, because I'm on the wrong screen. There we go. Right then. Let's just get rid of that. Right then. So let's boot these things. We'll start with the big image. So this is the one that's got the desktop integrated as well, and therefore its boot process is slightly different. And we'll just look at this as like our starting position. As time is going on, I am less interested in the integrated desktop on this thing, because it's getting to a point where everything's sort of firmed up and stable. So I could build retro home images underwater. Well, with some caveats, but I do scuba dive. It could be an interesting project, I suppose. So let's bring up the capture view. We're going to turn the Raspberry Pi on. And we'll see what we get. So we should see, for the first time, the boot splash. So this is obviously the bootloader screen, I haven't disabled this splash because it's a useful visual indicator that I haven't screwed things up in the boot process. And now we have darkness. And again, thank you Systemd for making this possible, because I didn't want anything on the screen. So you'll see that because of my screensaver. So this is the first piece of my splash screen. This is now using the frame buffer, and now it will, this is a slightly different boot process, and now you'll see the little animation running. So what's happened there is we've started on the frame buffer, handed over to the display manager, it then handed over to the display server, and along that chain it then introduced an animation. So you get an initial static image and eventually an animated image. So this is equivalent to what you can do with Plymouth, but very much geared towards fast boot. So that was the first boot of this system ever, and a bunch of stuff happened there. It grew the file system to the full capacity of the card. It created 1 GB swap. It rebuilt the font cache and a bunch of other stuff, and booted the system. This is the slowest boot you will ever see because it's also on the desktop system. And you will also have noticed that I have switched to dark mode because my daughter told me so. So Ludo is now by default in dark mode. So here we go. Our system is up and running. I'm not going to sit around in here for too long because we'll go and look at some stuff. But when we look down the list here, we will see that SSH is enabled, Samba is disabled, Bluetooth is enabled. This is the default. And the whole system reflects these preferences now. So I'm going to kill Ludo, which will drop us back to the display manager, and we'll log into the micro desktop because then we can have a little play with a new feature. And again, we use this splash consistently throughout now. So it's just a nice visual bit of consistency so we know what's going on. So I can see something's not right, something I've forgotten to change. So and this is untested, so I hope this works. So retro home is the session that takes us into the emulator, and then retro desktop is my rebranding of the flashback session, and I need to use the right keyboard. There we go. So hopefully this will take us into a session. So there we go. So we're now in our desktop session, which you should also see is hopefully dark throughout because we're now in dark mode. Okay. And then I'll just try and use the right keyboard. So let's just take a look at the running processes. We need to customize this so it's not Ubuntu purple. But if I, first of all, make it a bit bigger. Now, one of the big improvements that you should just be expected is it's actually using fonts. So if we look in here, this is brought up our micro desktop, and somewhere in here, I'm hoping, I'm not seeing it bother. Maybe I've got something wrong. Okay, so something that should have come up hasn't come up by the looks of it. So that will require some work. Yeah. Okay. So I'll show you what I mean. What I was looking for. Oh gosh, this is a weird keyboard layout. It's not even mapped correctly. Guess that's the right thing. Let's do that. Yeah, it's not there. So I was just looking for my watch service, which I don't see. So let's just have a look in config. Okay, that's entirely missing, so that's not right. So I've got something wrong in the way that the account's being created there. So that's a minor issue. What we'll do is we'll run this thing by hand. So let's run watch Ludo settings. So that is the thing that's now looking at the Ludo configuration file. And what we'll do is go and launch Ludo. And we'll just put a couple of, oh yeah, it's going to go full screen and back again. So actually, there's another feature we can demonstrate here. So this is Ludo, and we'll just say, don't do full screen because we're now in the desktop. So here's Ludo running. And then for funsies, if I change this, there we go. The desktop then changed to a light theme as well. So there's our integration between the emulator and the desktop session. And as I say, we'll try and use that for something more impressive in the future, where we can add some additional security around the SSH daemon, or more efficiency around the Bluetooth stack, for example. So, but this just demonstrates if it was, I don't know why it's absent, so I will have to go and fix that. But it hasn't brought in the auto start file to bring that up inside the desktop session automatically. So I think what we will go and look at is if that has come up correctly in the emulation session, the default session. So what we'll do is we'll just close Ludo. And we'll quit this watcher here, and I'll show you something else that's rather important, because this caught me out. I've done this before, made Ludo not full screen, and then booted into full Ludo mode, and then it's not full screen, it's a tiny window in the corner of the screen. So one of the things we've done is in user local bin is the thing that brings up the retro home session, and we have this here so that when we're bringing up the full Ludo mode, it actually makes sure that we put the thing in full screen mode. So we'll go and check that that works, because if we cat this file here, we will see that full screen is currently set to false. So let's exit out of here. In fact, let's just restart the whole box, because this boot should be a little bit quicker, and we can actually look at what the boot performance looks like. But this should be representative, because that first boot there's an awful lot going on, and now all of those awful long processes should have been initialized, so subsequent boots should be quicker. So what we'll do is we'll let this boot, and then we'll go and take a look and see, well, how does that boot performance look? This is still not going to be great, because in this version with the desktop shipped alongside, we do use the display manager in order to bring up the session, and that's a lot slower than just using our own systemd unit to bring up the display server directly ourselves. So we'll compare the difference between the two. And this was what we were working on last stream in order to think about handheld devices. So here we go. The good news is, even though the configuration said display it in a window, the auto correction has taken place. And again, although I'm handling that with a little integration, what I'm thinking is I'll submit a patch to Ludo, because my reading of Ludo OS mode is basically its kiosk mode. I think that Ludo OS mode should always just ignore the full screen option and always be full screen, because its whole purpose is it's in, 1000-foot mode. So let's do this. Let's go over here and bring up a terminal. We'll SSH into the box and have a little poke around. Now I need to use this keyboard, so I'll have to get rid of my keys because this is a new let's get on the right screen. Right, let's go back in. Okay, so here we go. We can see here these are our modifications to the message of the day. Interesting with this font there, offset by 1. Yeah, man, Unicode is hard. I'll have to think about that. So this is our modifications to that there, and if we just take a look at the entire process tree, this is what we're getting here. So we have some additional services when we've got that desktop bundle, like the account services daemon, which we need for the login manager. This is our case drivers that we worked on last week. WPA supplicant is back, as I explained, and then here we're using, you know, LightDM as the display manager, and then that's what brings up our session. And here's our watcher that's looking for those config changes. Lurk is here because of the case that I'm using. It automatically sets that up. Here's SSH, that's all fine. Here's Pipewire, again, that's been a huge success. And here's Bluetooth stuff, and then things to hide the mouse cursor on this screen here. So as I wiggle the right mouse, as I wiggle the mouse around, you don't see a mouse cursor on the screen though, which is desirable, of course. It's designed to be controlled by a controller. So let's just take a quick look at how long it took to get to the stages here. So this is interesting in itself. One of the things I've learned is how long it takes the Pi kernel to actually, you know, come up to a point where the rest of user space starts to kick in. So it's between 3 and 4 seconds, you know, depending on the flash card. But we got to the graphical target in 16 seconds. And that means that was the first point at which I could put an image on screen, which is quite a long time to wait. And if we look at blame, we can see where some of this is now. Of course, this is all parallel, so none of these things actually delay the boot by this amount of time. So this doesn't add 13 seconds to the boot time. This is just how long it took for this service to get to a point of completion. But this was running in parallel with everything else. But there are certain services that can't come up until this one has completed. But this is the one that hurts the Raspberry Pi. This is what brings up the UART for the Bluetooth device. And it is slow. And so that's why I'm thinking if I add systemd drop-ins for this unit, and there's another one called BT Helper, then when Bluetooth is disabled by Ludo, those would never need to start, which would bring down, you know, the boot time quite considerably. But then we can use that settings watcher to then bring up those additional units when Bluetooth is enabled to make sure the full stack gets turned on. So this is all pretty decent, actually. I mean, you can see down here, you know, anything under 500 milliseconds, you know, is fine. Interesting that that's running. That shouldn't be happening. That shouldn't be happening. I've got a bug. Because on this system, we're actually using LightDM here. We don't need for that to be there at all. So I've got a bug in my build system that's introducing this display server process. So that's a bug I need to fix. Yeah, okay, Yannick, I'll tinker with that after the fact. Yannick's suggesting some improvements to the cool retro term. Okay, so I've got a bug I need to investigate there. So that's 2 bugs we've identified. One is, why is this unit in the desktop image, and why is the settings watcher not enabled in the desktop session? So those are probably 2 easy things to track down. And then if we look at system couple list depend NCs and graphical target, So this is, yeah, so here we go. There's this failing. Rightly so. It shouldn't be there because it's actually light DM. So I think we may be hampering the performance here by doubling up on this. But if we look further down here, you can see here are my main scripts running in the basic target to make sure our Samba config is correct and that, you know, permissions are set and that the font cache is present. And I think I've got some further down here. We should see somewhere down here. Here we go. Here's the splash FBI. So this is the initial unit that brings up the static image on the frame buffer. So you can see that's happening quite early in the process, which means we get something on the screen before the display server comes up. So we've got a problem to investigate. That one there. That's fine. That's fine. And let's do this. So if we have a look, so the actual image size is 5.5 gig now that we've got things like swap enabled. So there's swap, and that's brought up by a systemd unit. So there's a 1 gig ZSwap file there. So other than a couple of minor bugs, that's looking pretty good. We've got just 2 small things. So what we'll do now is so it's interesting. Yannick says I thought the splash FBI is the screen that said piracy is a crime on open games you bought. Yeah, remember why? In fact, we're going to see some of those when we get to the actual emulation of arcade games. The author of FBI has actually written something in their documentation about why it's called FBI, because obviously it's garnered some attention at some point or other. But yeah, it's my poor man's replacement for so yeah, so I think what we'll do is we'll put the small image on now. We should see a significant increase in boot performance because there's clearly a bug here I need to track down. But we'll also do this. So hang on a minute, let's come down here. Hello Takop, how you doing? So Takop has been working away on back-end stuff. Yes, that shouldn't be there. That's as a result of the build process, so that's a good catch. Let's go and deal with that now. Let's go and let's go and get that out. Good spot. So Sparky Geek said that /wget log looks odd. Good eyes, by the way. So let's just think. I think that is an appropriate place to put this. So this will be root. There we go. That is dealt with. Thank you for pointing that out. So yeah, Takov's been helping, and we'll be getting into like the emulation side of it and also more of the case enablement side of it in the subsequent streams. This is almost the end of the deep internals, but this is to ensure that we've got the right bits to build on moving forward. And I'm pretty happy with where we are at the moment. I'm not going to go hunting down those other bugs because I do want to see the how the other thing works. So we'll do this, and this is our case driver, should be in full effect again. So power. Let's try power off, shall we? Try the actual words. So that's currently blue. Hopefully you can see, and it takes 8 seconds for the MCU to actually power off. So we should see that go red in a moment. There it is. That's just gone red. So that's our case driver for this particular case. Again, via system D unit, in power off conditions, telling the MCU to power down, which cuts all the power off to the device. What have you. So that's all good. And obviously our case fan is still working. We worked on. So Tacob, I think I might be able to help with like testing, getting stuff to you to test on. We'll discuss that in Discord. So I'm gonna bring up this again. This is a 64 gig card this time with the mini version of Retro Home on it. So that means there is none of the desktop stuff in it. This is just the version which is just the emulation front end, and this is the as small as can be. You know, it could be smaller, but it's small enough. So in this case, Yannick, it doesn't use GPIO. It uses a serial converter on the daughter board. So it actually is connecting to a serial interface and sending encoded data packets to control the fan and shut power off and things like that. It is quite nice. It's quite easy to work with. There we go. So here we are again. This all looks very familiar. In fact, it should look pretty identical. So I'm just going to press escape, because what we should notice is it should just cycle round and bring us back into Ludo again. And there we go. So here's our animated splash. And the way that this works is, I'll show you actually in just a moment. But there's two components to the main, technically three, but there's two main components. So that's all working fine. Let's SSH in and take a little look at what's going on here. So again, we're going to need to dump our keys. And that's fine. So if we just take a little look at what's in memory, we'll see that there's fewer services. There's no account service. I did consider swapping out our syslog for the old inet d syslog, but the savings just weren't worth the hassle, frankly. I can't see I'm gonna need to get that low down with it. This is all fine. And then here is our session being brought up, which has our settings watcher. And again, that's kind of pointless because there's no desktop here, but it's a view to doing these other service integrations. So that's all fine. One thing I didn't do before, which is probably worth taking a look at, is that's running in 281 megabytes, which is not too shabby, because like the lower end of what we're targeting in is 512, so that's not too bad. And again, you know, you could shut off Bluetooth and SSH and save a bit more maybe as well, that, you know. So but we've turned off everything that we don't need. We're going to reboot this one again, because I want to see, well, in fact, let's have a look. Let's do systemd analyze time. So this was a boot that involved doing all of the file system expansion. As you can see, so we got to the graphical target after 11 seconds, and I'm trying to get to 9. That's my target at the moment. You need something to shoot for. And we're way off that on the desktop, and that's because there's so many additional bits in the chain. But we've spotted a bug there, so maybe we can fix that. So, but again, this first boot did all of that file system expansion and all of that stuff, and creating swap and what have you. So again, but here the smaller image, this is 3 gigabytes. So when you consider 1 gigabyte of that is the swap partition, that means there's 2 gigabytes of the actual OS to make all of this go. So let's reboot, and we'll switch back to the capture view, because then we can see the device come up. So there's one thing I can do to help, and there's a mandatory default 1 second delay in the Pi bootloader, which we could disable. So when the bootloader splash goes away, that's when the kernel's coming up. Here's our static image. This is the first part of our notification. And I'm quite happy with how in this version, the miniature version, how things are chained together. And then when you see the animation starting to tick, which should now, that means the display server is up, and we're now displaying on the display server, not the frame buffer. So that transition, it looks a bit more janky on my capture card because the capture card does that no signal as it switches resolutions, but so we need to work on our timing here. So this this is interesting. This is, I've got a little script that works around a bug in Ludo, and actually I saw last night somebody's patched this bug in Ludo itself. So at some point I'm going to have to get into making custom builds of Ludo with cherry-picked patches, because there's some good stuff. I will now SSH back into this box. So let's see what the time was on this one. 16 seconds, so that doesn't make any sense. How is that possible? Very confused by why I see such varying times sometimes. Testing this at home, I had it at 9 seconds all the time. And none of this is causing a problem. So that's significantly longer here. I do have a funny way of connecting to the internet here, of course. So, okay, well that's a bit confusing to me, because what I'm interested in is trying to get the graphical target to 9 seconds. I'm surprised at the 16 here. Well, boot speed aside, it does all of the right things in the right order. So oh no, I don't want to power off. Let's just reboot it one more time. And see what another run looks like. So I started to think about like the next steps. Obviously Takov and I have got a bunch of cases we want to make work, which is kind of the point of this, because I've got cases that family are using that are a bit janky set up, and I want to get new images on them so they've got better systems. It turns up the old SNES game Donkey Kong Country, my niece and my daughter absolutely flipping love that game. Flipping love that game. So the SNES consoles are getting a lot of attention. But it's on a really old build from like December, and the performance is not great by comparison to this one, so I really want to get them an updated image. My daughter played this one at the weekend, and that's where we got the idea to go dark mode by default, because we had it on the big telly, and Ludo, well I'll show you, Ludo's default is light mode, which looks like this, and that on a big panel, it's a bit like staring at the sun. It's a bit too much. So this was where my daughter pointed out, dark mode by default please. So my daughter has spoken. So let's just go back into the box again. Let's just see. Yeah, it's way different. I simply cannot compare doing this at home. At home, these times are 9 seconds, and here they're 15. And I'm also using the faster SD cards here, so it's clearly not SD card related. You go and get some food then, Yannick. Right, okay. So I think we'll just go and take a look and see if we can figure out why we've got the X11 thing when we don't need it on the desktop version of the image, and go and see if we can figure out why it's not enabling the auto start file. So I think what I'll do is power this one off and boot up the full image again so that I've got a place to test. And then we'll go and look at the build scripts and see if we can fix those two things. Alignment of the chat line makes my eyes twitch. The chat line? The chat line. What do you mean? I'm not sure I understand. Right, let's... Oh, yeah, I know. It's weird, isn't it? So, this is because that particular Unicode character is like 2.5 bytes or something. So I need to find a different emoji that is precisely 2 bytes so that it aligns with all of the others. I will, but yes, I am aware. I am aware. Yeah. Yeah, this is the perennial problem of working with Unicode. Right then, let's have a think. So let's power this one back on and let's go over to the code editor and see, first of all, the big issue is why the display server is coming up at the wrong time, or coming up at all in the desktop image. So here is where we copy it in and enable it. And that is being done all the time. That's why that's a problem. That should fix that problem. There we go. So there's just a conditional here that says if we're including the desktop, install the display manager, else just provide X in it. So we'll add this piece here, and that fixes the first problem of having effectively 2 services that are trying to compete for the graphical target. So that should fix that problem. And the other one was much more curious. So let's try looking in root. Let's see. Oh, I bet I know what it is. Okay, let's go and take a little look, see if this is... So that's the desktop file. Let's go and see if that exists. This is the auto start file to bring up that watcher in the desktop session. Let's head over to the SSH session, which is here. Oh, I need to dump the keys again because it's effectively a different machine. Same computer, different card. Right then, let's have a think about this. There's no auto start tool in there. So, there it is. So, why didn't it pull that over? When it created the user is... Oh, it's not. So the scale hasn't been replicated. I mean, I wanted to get rid of this thing anyway. I'll explain why in just a moment. Right then. Yeah, we are aware of that offset in the message of the day. Yeah, we'll get there. Yeah, sack thing. It's first time out we're trying that. In fact, I tell you what, as that's causing. Let's see if we can do anything about this. Can I do edit? Let's see if we can turn this down a bit. So, I think it was, what was it? One of these. Thought it was, is it brightness? There we go. Hopefully that's a little less jarring. Right then. So it hasn't brought over any of the configuration changes at all, as it happens. So they're in. So I didn't want to do it this way, as it happened. I think what I'm going to do is I've got another tool, which is basically like a session initializer that runs in the user context at login early in the login phase. So I think what I'm going to do is I'm going to employ that, because I meant to do that because I only jammed thing into Etsy Scale in order to like get it working quickly. As it happens, it doesn't work, and I'm not comfortable with just dropping things into Etsy Scale anyway. So I think what I'll do is I'll replace that with the little settings overlay, user session initialization stuff, because that's the right thing to do. And then it's a bit more predictable as well in how it's going to work. So I think that's how we'll address that. So let me talk a little bit about what the next steps are going to be for the project as a whole. So we've talked about case drivers. There's a whole bunch of case drivers that we need to, well, we've implemented some of them, but Takov's got some good ideas about sort of unifying and consolidating how all the ones that use GPIO headers can be made out of the same framework of tooling, which is terrific, and I'm all for that. But then what I've started to look at is the business of emulating things, and Ludo is not designed to emulate absolutely everything imaginable. It's very much about arcade and classic console emulation, not so much about like 16 and 8-bit computer emulation, which is fine. But the problem is that the libretro buildbot service hasn't been building Linux binaries for ARM for 2 years. So the libretro cores from the RetroArch buildbot are ancient, and I think in some cases there's some compatibility issues, not just in terms of like the quality of the emulation, but the actual like compatibility issues due to their age. So I have found out that there is someone in the Ubuntu community who has been doing a ton of work building current versions of RetroArch cores in an Ubuntu PPA. So I've had a quick look there, and some of the more interesting cores, the cores that are going to get used by most people, so things for the Sega consoles, for the Nintendo consoles, for the arcade game emulation, there are definitely newer cores available there. And I'm going to take a look at that and see if we can work with them in order to fill in some of the other gaps that exist, in order to get like a current portfolio of the emulation cores that are going to be needed. Because that'd be nice to then hook that in so that we can maybe have an update capability in the future where you can safely update your console and get, you know, current and compatible stuff. So that's something I want to look at. There's quite a big lift there, and we've got the case enablement. So I think what Takeoff and I need to do is have a bit of a chat and figure out how we tackle some of that. And I think we'll have to work on a few bits behind the scenes. So I'm thinking that the next stream I do about Retro Home is probably going to be this time next week. And maybe the streams I do on Monday and Wednesday next week will be updating DebGet, because there's been a ton of work going on there and there's some cool new features stacked up. And then QuickEmu as well, the same. There's a bunch of pull requests and fixes from various people. I think both of those projects need to be given some attention. So I think whilst Takov and I work out some details in the background, we'll get those other two projects uplifted, up to date, new versions released, and then next Friday hopefully we'll have done a bit of work on Retro Home to sort of move it into the next step. But the other thing I need to do is some of the optimizations that I've talked about today and the last stream in Retro Home, I want to bring back into the Ubuntu Mate images for the Raspberry Pi, because there's a couple of benefits there. Not least, the desktop team have done me a favour and built an additional package that I needed as well. So I'll be, over the weekend, probably wrapping up those Ubuntu Mate images for the Raspberry Pi. So I might talk a little bit about that next week as well, because I'm thinking they'll be published over the weekend. So for Retro Home, we can start to pivot away from this low-level plumbing stuff and like the build scripts, and start to look at the emulation side of things and getting that emulation integrated with the cases that we're interested in. SAC thing, I'm glad those retro effects are a bit better. Yeah, I'll take a look at that. And I wanted to do something that was a bit more interesting, but I realised that was a little bit a bit much. So I'll tweak those settings and come up with some setup that's interesting, but not too hard on the eyes. But thanks for the feedback, by the way. So let's think about this. I need to get a bunch of stuff pushed up. So let's go here. So we should have a few changes that we can probably push up. The retro desktop worked, didn't it? In fact, I need to test that. There's a feature I need to test. So this is the full size image. So I'm going to drop out to the display manager. And here we go. And then I want to make sure that we can log into the thing called Retro Desktop, because I think that's just, it just looks a bit neater calling it Retro Home and Restaurant. But I need to make sure that I can see the network connection manager in the menus, because I'm concerned that I've changed the desktop session name and that might be hidden. Yeah, it is. So I need to do some work here as well, because in making that name change, it has hidden some menus. So what we need to do is, if we do let's think about this. This is going to be user share GNOME flashback. So this is the namespace of the session where some of the session files live, and if we link that to user share retro desktop and update the desktop database, and realize that this is also frustratingly small, so database. Okay, and then we'll use the right mouse to log out. Oh gosh, go away. Use the right mouse to log out. And then we'll log back in again. Okay, thank you very much. That was OBS crashing again. So among the things I need to work on is maybe taking a look at OBS and figuring out why it's done that to me twice in 2 weeks, because that's a new experience. Right, I'll just carry on with where I was. I'm going to assume everything's going to be fine. Indeed, a fireball, Henrik, a fireball indeed. Right then, that was, I would say, fun. That's never fun. And my bitrate is up and down at the moment, so I might just give that a prod and see if we can make it play nice. Twitch is not happy. I'm not going to touch anything. Please type if things are totally busted. Last thing we saw, let me log out. Let me log out. Yes, I was going to log out of the Raspberry Pi. Thank you for the prompt. So I will do that thing now. I was a bit confused as to what exactly had crashed, because two things happened at the same time and it was very confusing as to what I was looking at. So we're going to log out of the Raspberry Pi. Yeah, King Egypt, I know. So we'll be looking at OBS at some point as well. And then we'll log back into the Raspberry Pi. So I think I got this far. Yeah, I did do this, but it all fell apart.
OBS to birth.
Thank you, Troy. That's very kind, considering the lack of professionalism going on around here. But what we'll see now is, hopefully, if I'm right, there we go. There's our connection manager settings icon back. So what we'll do is we'll make that change in the build script because it's clearly required, and that should be here somewhere in the desktop stage. I think I've got a placeholder for it somewhere, but I wasn't certain if it was going to be needed, but that test proves it is. So here, so we do need that. And this is because I've changed the name of the session effectively, and I may do some more here. So what I might go as far as to do is to create my own desktop session, bring up script, and rename everything so it stands apart entirely, rather than reusing some stuff. But for the moment, that will be enough. So I've got one bug left, and I've said I'm going to fix that the right way by doing a proper settings overlay. So that's something I'm not going to do now because I'm running out of time to work on stuff like that.
Follow Arminius 3301.
Thank you very much for the follow and welcome to the stream. Thank you. So yeah, I think that really it's just that session bring up. I think that might be a latent trigger that's running there. Right. So yeah, so I think the next time we have a look at Retro Home, we'll see the Chelsea cucumber indeed. So Troy says I'll have to watch this. It's 5:30 a.m. for me. Yeah, we'll get some sleep. Don't get up too early. That'll ruin your day. That will. Let's see. Let's go and head back to the capture view. We're in the full desktop mode, so let's do a full restart and let the full emulation mode come up. Then we'll try turning on Samba, and I've got a rather unusual network set up here, but we'll see if we can get this to work. I think we'll just see if we can put some games on and if they run appropriately. So let's just see if those things all work together in harmony. Anyway, I'm pretty happy with where things are. Something else. I talked about, improving the emulation cores and the case drivers. Something else I thought about, I forget which one it is, but some months ago I looked at some of the other emulation OSs, and one of them has got a selection of homebrew games for the different consoles and what have you, and they preload them, and I thought that was a great idea, because then that means when you start this thing up, it won't be empty. You'll actually have some consoles defined with some games in there. So I want to go and look at those and figure out which ones are redistributable, and ship this with a small selection of games that mean that by default it does something, because as you can see at the moment it actually doesn't. So we'll also check that our case drivers work and that the controller that's plugged in the front work. It does. So let's go and turn on Samba. So that should be Samba enabled. Now let's go back here to my computer and open up File Manager, which will bring down onto the right display. And we'll take a look at the... Here it is. Here's our Desk Pi. Open. Why is it does this? Or it'll go round this loop and then it will work. I need to investigate why this is so picky. Anyway, there we go. So ROMs. Connect. So this is the ROMs directory on the Raspberry Pi. We'll just bring down another. Oops. Let's just make this one a bit smaller. And I'll just get to the right spot because I've got a sample selection somewhere. I'm just doing this off screen, but I'll bring it down. It's samples. There it is. So we'll just bring in those ones. Drop those in there. So it's not a huge number, it's just a selection, but enough that we can scan them and go and start them up and see what works. So if we go back to our Pi now, we can turn Samba off. In fact, it's the first thing we can do. So we'll turn that off. We will then go to add some games and say scan this directory. So let's just go and pick those up, see how this is working, see that we haven't got any regressions in performance. We shouldn't have, although whoops, I didn't mean to do that. Scanning them again, press the wrong button. Right, there we go. So if we come out of here, we've now got a selection of consoles to choose from. So we've got some arcade things, some NES, Super Nintendo, Master System. This is where I think there's some bugs in the cores, and which I've just talked about addressing, because a lot of these are not... Oops, oh, I've started it. There we go. So that's Aladdin for, is this the Mega Drive? I think it is, isn't it? And in fact, I've even got, if I press that button here, this is, what console is this? This was the Mega Drive, right? If I press this button here on my Stream Deck, hey, there we go. I pre-programmed a bunch of appropriate resolutions so you can maximize the... I don't know how to play this game, by the way. But there we go. Oh, this is working fine. I can immediately see. I'm not reading any of that. I'm just going to assume I know what to do. Never played it. Okay, so, well, this works Wow, actually, so I played this once before. I have to jump over that, I assume. Whoop. Can I beat those people? No, that's the right button, okay. Oops, I didn't mean to do that, did I? Did I do anything with him? Okay. Well, I suppose what I should do is do something like go here and pause the Stream Deck. There we go. Not Stream Deck, Spotify. Whoop. What's the purpose of this? Is that so I can get up somewhere else? Okay, well that works. I'm now going to put something on that I'm familiar with, that I know whether or not the emulation is busted. So if I push this button, no, that's just pause. That's just pause. And this button here, there we go. So let's go back and choose a different device. I could just do 1942. It's my go-to. This one, music can cause it to stutter a bit. So I now need to go back to my thing here and say arcade vertical mode. There we go. I'm glad I programmed up those different things. Hey Charafu, how you doing? Yeah, boot speed. Oh yeah, we've got past the boot speed optimizing. I'm now just checking that the rest of the stuff hasn't degraded. So put a coin in, hit play. So this should all be working just fine. Yeah, that's working just fine. The thing about this is that the music in this game can introduce, because the sound emulation is linked to the frame rate of the emulation in Ludo. So if you've got any hiccups in the audio, it really impacts the rest of the experience. So this is a good test to sort of make sure that everything's ticking along correctly. And it seems to be. Yeah, Bomb Jack is an absolute classic. I used to be really good at this game, like back in the day. But oh nuts! I've missed my. Oh, ooh, that was rather fortunate. Nuts. Anyway, Bomb Jack is a great game if you've never played it. It's absolutely fab. Oh, bother. Right, okay. Let's hit that button and this button. Let's think. I don't think I've got any massively demanding titles on here. I think we've got a Final Fight. We'll do it. And I must have something on here that will really push the... It's... Hang on, not enough. MK doesn't really push things hard enough. I want something that drives the sound a bit harder, and it's not Outrun, although I love Outrun. Oh, Power Drift. This will do it. This pushes things pretty hard. In fact, actually, R-Type Leo. That's where we should go. And we'll do that one. There we go. So this does enough to push the audio that if it's not...
Thank you for the follow, Danacron5.
Hey Danacron, how you doing? Thanks for stopping by. So let's drop a coin in. Let's hit start. Yeah, okay, this is great. So it's fascinating. So the OpenAL stuff that this uses requires pulse, but I'm using Pipewire, and it's been so much better since we've made that change. This is terrific, in fact. So, like I say, the speed of the graphics is what dictates the audio sampling and reproduction. So this is fab, in fact. So
thank you for the follow, Sapling 123.
So this is where we're getting to, in that eventually the focus of the rest of the project will be improving how this emulation stuff works, and actually finishing this to a point where when you download this thing, you can stick it on your Raspberry Pi in one of the, you know, gaming cases, and everything should just work out of the box, as it indeed is happening here. You know, the controller's working correctly, and some of them are going to require bespoke controller drivers and stuff, which we're going to work on. But well, I tell you what, I'm going to have to stop playing, otherwise I might have to play this one with my daughter later, actually. So anyway, that's working really nicely. I think we're in a good spot here. So over the last couple of weeks, we've done a load of work to improve the optimization and the hardware enablement and what have you, and this is kind of proving that it was all worthwhile, because now it works beautifully. So yeah, we can push on with the rest of the emulation stuff now, although this is going to be hard to put down. Gosh. Nuts, that's bad. That's never a good thing. Oh no! That's never the outcome you want. Oh dear, lost everything in the process. That was bad. Right, well, we get the idea. I think we'll call that there. That was good. Right, okay, we get the idea. So this is where we're aiming towards, is to actually get to the point where these things that you can put in your front room and have some fun with. Right, let's just push a few buttons here. Like that one. There we go. Right then, and then let's come back here. Oof, okay, well, all works. Tyrion. Okay, Charafu, I'll look that one up. I don't remember it. I don't remember that one. I did do a thing around Christmas time where we had everything available that it could play, and I was basically asking people, what can you think of that is demanding? And I think we'll have to do something like that in the future, to actually find those demanding games and make sure those are the ones that are working well, to actually test that we've got all of the audio and video subsystems lined up as best as possible. But definitely, although I haven't published this build yet, oh, I say I've gone out of focus. I haven't published this build yet. It's way better than that build we made at Christmas time. So I think we'll have to get a new build out in the next couple of weeks, just for the generic Raspberry Pi stuff, because things are much improved now, and cooking on gas. So let's just head over here a second. Oh, awesome. Right then, I know where we're going. Let's click that button there. Right then. So this is a channel that I've not raided for some time, but they are doing some Flutter development. So what have you been doing lately with the Raspberry Pi 3? Well, this was a Raspberry Pi 4 that I was just testing, but the Raspberry Pi 3 is in some of these other cases here. So as we bring up the rest of these cases, we'll be working with the Pi 0, the Compute Module 3, the Compute Module 4, Raspberry Pi 2, Raspberry Pi 3. So we'll be covering off pretty much all of them except for the OG Raspberry Pi and the Raspberry Pi 1A, or A+, whatever it's called. Basically everything that can support ARM7 instructions and up, we will touch at some point as we get all of this stuff going. So yes, Phil, you've got that right. I hope everyone has a fantastic weekend. I've got a long weekend of doing stuff with my daughter ahead of me, which I'm looking forward to. But have a fab weekend. I'll be back on Monday. I think it will be Deb Get on Monday, and we'll do some more Retro Homes stuff on Friday next week. But I hope to see you before then. Let's go raiding. Bye bye for now. See you soon.